Welcome, Lumka. Lumka, it seems like you don't have a... Oh, there we go. Lumka, can you hear us? Yes, you can. Awesome. Welcome. Welcome to Boitumelo as well. You guys are early birds. Early bird catches the worm, hey?
Who else is there? Let's have a look. Awesome. I'm quite a punctual person, so I appreciate the early birds. So while we just wait for everyone, Lumka and Boitumelo, if you want to give the questions on the board a go, I'm not going to say too much for a while, but please do give them a go while we wait for everyone. Okay. I quite enjoy drawing my pictures, so I'm going to indulge while we wait for the students. Ooh. That could be Table Mountain with the... Okay, who else have we got? Okay. What's the time now? It's just gone 5.
I'd love to hear how you guys are feeling. How's it being back at school? Are you guys already busy with a lot of work? Do you feel overwhelmed, or are you, do you have all your ducks in a row? We'd love to hear how it's going there.
I'm interested to know where you guys are in the country, if you don't mind popping us a message there. I'm always, somehow I find it very exciting when people are all over the country. Like, I'm living in the future.
Hi, Tsolofelo. Welcome.
Welcome, welcome.
You can start with the do now. And if you haven't yet shared where you live in the country, please feel free to either share that on the chat, or you can just unmute yourself and tell us yourself. It would be lovely to hear.
Welcome, Marilyn.
Hey, Marilyn.
Hi,
How are you?
I'm good and you?
Very good, thank you. So nice to hear your voice.
Absolutely.
Marilyn,
Where are
you can
you?
start. Oh, sorry, Peter.
No, I'm jumping the gun. Where are you, Marilyn, in the country?
Mafiking.
Mafeking. Awesome.
I was
So-
just gonna say, if you guys would like to start with the do now while we're waiting for everyone, then please go ahead. But yeah, in between, maybe Peter and I will ask some questions, and we don't want you guys to be shy. We'd love to get to know you. So like Marilyn, unmute yourselves, and if you want to, feel free to answer.
Totally. I'd love to see a face out there. So if anybody, while you're doing the do now questions, if someone is a Man United supporter, turn your video camera on. Are there any Man United supporters in the house? Or am I the only one here who supports Man United? Okay, well, maybe that wasn't the best question.
Hi,
Welcome,
Morgan.
Asamakle, welcome.
You guys can also start with the do now until we wait for the others to hop on.
I think we wait about another minute and then we get going.
Awesome. Well, for those who's been here before, you know how it works. Peter's going to lead us and guide us. And if you guys have any questions while he teaches you, please feel free to either unmute yourself or pop your question in the chat. And yeah, questions are really welcome. We love to hear from you guys. And then I will give over to him. I'll see you guys again at the end for the revision work. Enjoy.
Thanks, Ozan. So welcome, everyone. It's so lovely to see all you hardworking students joining us today. So I think most of you were in the first video, but if not, my name is Peter, and I'm taking you for this series on statistics and probability. And yeah, I'm pretty excited to be with you. And if you feel like you have a question, if you want to turn your mic on at any stage, you are allowed to, so please go ahead. Otherwise, the chat stream, like we said, is being monitored. And Ozan, feel free to jump in at any moment. If I miss something, or even if the question is a bit small or something, if I could just zoom in or zoom out, that would be super helpful. Because I know sometimes for students, it can be a little small or something, and you just don't see it because you're busy. Okay, I'm going to talk about the do now questions, and I'm going to answer them now. Well, in fact, I tell you what, let's actually have a little chat stream. I'm going to give 3 options, A, B, C, D. And just to get everybody's thumbs warmed up, I'm going to call this question number, oh, what's happening here? Question number 1. I'll call this question number 2, and I'll call this question number 3. I'll change my color. Put your answer to question number 1 in the chat stream. So in the last lesson, we spoke about something called the interquartile range. We spoke about quartiles. We spoke about percentiles. And I just want to see what you remember. And I'd love to see if anybody has got, if you can say which answer you think it is. And I haven't worked the answer out yet, so I don't even know. But I'll do that with you very shortly. Okay. I'm waiting for those answers. So do you think it's 1A? Do you think it's 1B? 1C? I'll give you a second to type it in. So just the act of committing to a choice actually helps you remember the right answer afterwards. Okay. All right. Can I zoom in a little bit? I absolutely can. Let me, how is that? Is that better? Ooh. I'll get rid of some of the other bits and pieces. So remember, we're on question number 1. And the first data point is 2022, and so on. Like everybody, I'm still mastering the art of writing electronically. Yes, thanks. D. Okay, some answers coming in. D. Anybody else think it's D? Okay, so one of the things is we do want to have a pen and a piece of paper, and you want to actively be participating in this. I know it is easy to just watch, and I would be the same some of the time, but we just know from learning theory that actively being involved, our brain is going to be taking in so much more. So I encourage you to give it a go if you can. If you're stuck somewhere where you can't input the text, totally understand, but just throwing out there one more time, and then I'll speed up a bit. Okay, so, okay, we have a D. Oh, Ozan. Okay, we'll find out. Oh, D as well. Okay, the D's for donuts. Let's see. Okay, so the first thing we need to check is if we're going to find the interquartile range, is the data arranged from smallest to biggest? And it turns out it is. So that's all good there. Then we have to ask ourselves, how many data items are there in the list? And in this list, there are 5 data items. But now the formula in the previous question that I used to find the position, actually, let me backtrack for a second. In order to find the interquartile range, I first need to find quartile 3 and quartile 1. When I find those, I can find the interquartile range. In order to find the first quartile and the third quartile, I need to know its position. And in the last lesson, the formula I was using was I was taking the number of items, I was adding one, and then I was timesing by a amount. And for the first quartile, what I did was I said, sorry, the colors keep changing, a quarter times n plus 1 or a quarter times 6 to find the position of the first quartile. Now, position 1.5 is actually just going to be over here between 20 and 22. And so Q1 is really going to be just 21. Now, in order to find the third quartile, I do the same thing, except the position is now going to be 4.5. And so 4.5's position is 1, 2, 3, 4. It's halfway between here, which is 30. And then to find the interquartile range, I need to go 30 minus 21, which is 9. And so all my smarty pants is well done. Okay, so that was something from the previous lesson. Then the next thing was about identifying data, different types of data. And there's qualitative and quantitative, basically numbers that are data, that are numbers, and data that is words. And then we have continuous and discrete. So the number of rooms in the house is definitely a number, but it's a discrete number, let's say, because it might be 9, or it might be 7, or it might be 2. So we call this discrete numerical data. Foot lengths could be 27.5 centimeters, it could be 27.777 and so on. And so this would be continuous quantitative data. Heads or tails is just words, so we would call that either qualitative data or categorical data. The amount of water drunk in the day would be continuous, because you could have like 1 1/3 and 3/4 cups. A house, shack, flat, or informal dwelling, that will be qualitative. And then the time taken to travel to school will be continuous. And that will be also a numerical data or quantitative data. And then the last do now that I did was basically I had to find the mean, and the mean would mean adding up all the items. So 17 plus 12 is 29, 35, 45. So 45 divided by 5 items, and the answer would be 9. Okay, so that is our remembering from last time. And I want to move on to now onto today's main topic, which is basically the standard deviation and then representing calculations graphically. Now, before I do this, I just want to make you aware of a website that is very relevant if you're studying stats or data, and that's something called Stats SA. And if you ever want to know about statistics in South Africa, this is the official government department that deals with it. And a lot of the examples that I'm using today are taken from a book that Stats SA puts out. And so, yeah, if you're curious about stats, go have a look at this. So in the last lesson, I wanted to introduce you, well, I was talking a little bit about measures of central tendency, or where the middle of the data is. So where the middle is, and that would be the mean, the mode, and the median, and also something called the measures of dispersion, or how spread out the data is. And the only measure of how spread out the data is was something called the range. Now, I want you to look at the data set over here, and I want you to find me the range for this data set. And I want you then to put that range in the chat. So the first question, before we even get to what something there is, I want you to find the range for the data set that is in front of you here. There are 12 data points. I'll wait for your answer. What am I looking for if I want to find the range? Don't I need the biggest and the smallest? Let's see if we can find the biggest. I think that to me looks like the biggest, unless please jump in if I'm wrong. And what's the smallest? 121. And so if we take 865 minus 121, we get 744. Should I use my calculator? I have it here just to show you. No shame in using a calculator. 865 minus 121, 744. Winning at life. Okay. And here in this question, this is a measure of how spread out the data is. But this number 865, if it hadn't been 865, if it had been something like 10,000, okay, the measure of the range, or the measure called the range, is influenced by the highest and the smallest value, okay? And so if the highest value is way out of line with everything else, it doesn't really give us a good representation of the spread of the data or how spread out it is. So one of the things why we need to develop more maths is the range is great to give us a basic idea of how spread out something is. But the moment we have something called an outlier, which we'll talk about later, something that is maybe like a mistake that somebody made in the data capturing, it can be easily affected by that. And so we need a measure that is more robust or can handle like wrong values every now and again. And so that thing that we're going to learn about is called the standard deviation. Please give me a thumbs up if you've heard about the standard deviation before. And give me a thumbs down if you haven't ever heard of the standard deviation. Down, okay. Give me some more feedback, guys. And have you heard of this, what the standard deviation is? No? Keep them coming? Okay, fantastic. So it seems like I can add some value to you if I explain what it is. Okay, so in a word, the standard deviation is basically saying how far on average is any one data point from the mean. Okay, now remember the mean is something we've calculated before. So before I explain further, I want you to work out what is the mean for this data set. So you've got these 12 data points, and basically just grab your calculator, and I would like you to tell me what is the mean. And if we imagine like a number line, you're going to find me the mean for this data set. I'll give you a moment or two just to key that into your calculator. It's going to be divided by 12 because obviously there's 12 items. Okay. Actually, now that I think about it, it might take a little bit of time for you to do this if you don't have a calculator nearby. So I'm going to use my magic teacher powers and make the answer appear if I can get this to grow. Oh, Asamakle 501, is that your total? Let's have a look. I'm going to get this to work in a second. If I can just pull this. You guys are quite right. It is indeed 501 if we look at my answer. Now, what is this thing called the standard deviation, which the answer is already up on the board, but basically I want to explain what it is first. If all the other data points are very, very close to the mean, we say something has a low standard deviation, okay? But if the data points, I'm just using my Control Z to make this disappear, if the data points are far away, if like some of them are close, but some of them are far away from the mean, then we say it has a high standard deviation because on average, they're further away from the mean. So the standard deviation measures how far on average a data point is from the mean. If the data is all over the place, the standard deviation is high. If the data is all very close together, the standard deviation is normally low. Now, the calculation itself looks a little bit scary, but it's not, because we can just use our calculators, and I'm going to show you how to do that. Basically, what it says is you take a data point, that's the xi, and you take away the mean, which calculates how far it is from the mean. You square it, you then sum it up, divide by the number of items, and then square root it. And I suppose, you don't really have to know exactly why that works, but that's what it's doing. Now, if you want to use your calculator to do that, then these are the magic steps for doing it. So I want you to give you a moment, and I want to see, can you get the answer that is on the board by using your calculator? And the way you're going to do it is by following these prompts over here. So you are going to click on, the instructions are actually already on the board here, but basically you click on stat mode, which is up here, or mode, and then you're going to choose stat. And then what you're going to do is you're going to choose 1, and then you're going to be able to, I don't know, probably giving you guys a bit of a headache with all this jumping around. I just thought this was the easiest way to do it. You get that. Okay, so I want you to try and put in, you basically hit stat, 1 for var, or for variance, and then you should get a table, and then you plug in the values 356, 525, 743, and so on. You then hit AC, you then hit shift stat mode. Sorry, Siri is going off.
1 sec. I didn't get that. Could you try again?
Yes, Siri. And then you click on var. I know, it's funny. So I want you to try for a moment and see if you can use your calculator to get the standard deviation of this data set here. And you should get 220 and 20.20. Actually, the best way to do it is probably just to follow the instructions. So you basically go mode 2.1, AC to save, then shift 1.4, and then you choose the standard deviation. Okay, if you've got it, put your thumbs up. If you haven't got it yet, put thumbs down. I know this is a little bit, maybe a bit too quick if you've never seen this before, but just see if you can get it, because if you get it, it's easy marks in the bag. Being able to calculate the standard deviation with your calculator. Or maybe you should jump on the audio and ask like, if you get lost, let me know where you get lost, and maybe I can help you. I thought the pictures were very clever. I'm not so sure if they're actually working out that way, but hopefully it's making it a bit clearer. Tomato, we are waiting, so no problem. So you click stat, then 1 var, then you get this almost data table over here. And then what you do is you're going to put like 356 and you hit equals, 525 equals, and you get all the data points in there. Then you hit AC. And then the next step, you need to go into stats mode. And in stats mode, the way you get there is actually described on the left here, shift 1.4. So you hit shift, then you hit 1, and you'll get this screen. And then you click on 4 for variance. And then inside that, I think it is going to be the option for, I think it's option 3, or the standard deviation.
Oh, okay. Thank you, sir.
Okay, I know it's a bit complicated, but it is worth spending some time, and we're going to do another question now. Okay, I'm going to move on to the next one because I know you probably want a chance to really try this out. So this is a proper exam question from a past exam that I gave to one of my classes. And I want to see, can you do this based on what we learned right now? And those students who are feeling comfortable, I want you to go ahead and do it. Those who have questions, let's have you hop online, ask a question, and I'll explain it. So this is worth about 7 marks. So normally in an exam, you'd have about 5 minutes. So I'm going to give you put you on a little bit of pressure, maybe 3 to 4 minutes. And then those who can do it by yourself. Those who need some help, let me try and assist you where I can. And you can either chat in the text and Alzan can let me know, or you can, it's probably quicker to just ask your question audibly.
Peter, do you mind just zooming in a bit more, please?
No problem. How's that?
Perfect. Thank you.
Cheers. So to make life a bit easier, I'm going to show you what I would highlight. If I was writing this exam, what I would highlight to get me going. Because often I advise my students, take a highlighter and highlight the important bits. So it's the fastest person, and these are all times for a race. And then the second question is, where is the middle if I use the mean? Then the next question is, what is the standard deviation for this data? And then the last one, it asks you a question about this in relation to the standard deviation. Okay, so for now, I'm assuming you guys are busy little bees. And but if you do get stuck, please do ask a question. We're here to help. But yeah. I'm sure, Alzan, in your psychology studies, you come across the standard deviation, yes?
Yes, we did indeed.
It's very
That's the
popular in
only
psychology.
reason. That's the only reason why I can remember this. I can't remember this from school at all.
Because, yeah, when you're measuring groups of people, you want to know how far on average they are from the mean, basically. And some population groups or some groups have bigger standard deviations than others. Or even wildlife populations, like maybe an African giraffe species might have a smaller standard deviation than, from another area. Okay, so I'm going to give away the first one's answer. The how long in minutes to take the fastest person, it's actually going to be this one. The fastest person is going to take 4 minutes. And then the second question, I need to know how many items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know I need to divide by 10, but first I'm going to have to total it up. I would love someone to, if you've done the mean, put the mean in the chat and see if we get the same thing, or let's see if we're getting the same answer. 16.9 so far. Anybody else want to check that? I do have the answer in the background, but I'd love to see. Okay, so we have some variation. So far, 16.9 is the most popular. Anybody else get 16.9? Okay, so it seems like 16.9 is the most likely. If I check my answer, okay, well, I'll zoom in at the moment, but it seems like for now that seems reasonable. Okay, and what about the standard deviation? What are you guys getting for the standard deviation using your calculator? Because that's the new one. Okay, 5.79. Anybody else? Anyone get the same? Okay, so I'm going to show you the answer now. The answer is indeed 5.79 for the standard deviation. Struggling with the mean. Okay, all you need to do with the mean, Jason, is to just say how many items are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the mean is just, you divide by 10 and now you find the total. So you go 4 plus 12 plus 13 and you add them up and you should get, based on our thing, 169. And so that's why the mean is 16.9. Now, the standard deviation is a bit more of a complicated calculation. That's why we're using our calculators. And I encourage you to go back to the recording of this video and have a look at what I was going through there to find the standard deviation. But it is indeed 5.79. Okay. So that's just a calculator skill that you can practice. And then the last question, how many members of the team completed the obstacle race outside of 2 standard deviations of the mean? Okay, so first of all, what was the mean? It was 16.9. So in terms of our list, 16.9 would sit over there. Okay, now how big is 1 standard deviation is 5.79. So if I want to know what 2 standard deviations are, I'm going to have to just double that or times it by 2. So I'm going to use my calculator, 5.79 times 2, and I get 11.58. So that's the amount of 2 standard deviations. But I could have 2 standard deviations going this way, or I could have 2 standard deviations going that way. So what I'm going to do is I'm going to say 16.9 is the mean, and I'm using my calculator here, and I'm taking away 11.58, and I get 5.32, and that's going to fall over here. And then if I have to go the other direction, if I go 16.9 plus 11.58, that gives me 28.48. Now, where is that? Well, that's actually up here. So the question says, how many members of the team completed the obstacle race outside of 2 standard deviations of the mean? The only person I can see is this guy over here, the winner. He was 2 standard deviations outside the mean. And so we consider him, he's obviously clearly a very highly skilled athlete. If you've heard of someone like Usain Bolt is probably like 4 standard deviations above, he's or even more than that. So this idea of standard deviation showing us how common something is a useful idea. Okay, now we're going to have to practice this a bit more. And there's a practice coming up at the end of the lesson in our exit ticket. But for now, I'm going to move on from this calculations. And I'm going to move on to something called the 5-number summary and the box and whisker plot. And this is just a graph that we draw that represents the information that we've been calculating so far. So first of all, what is in the 5-number summary? Well, in the 5-number summary, we have the smallest number, or what we call the minimum. We have Q1, or the first quartile. We have Q2, or the median. We have Q3, and we have the maximum value. And sometimes people take this and put this in a bracket. And sometimes I'll even say, okay, well, how many items are there in total? And they call that N. But that depends on different textbooks. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So N is going to be 10, although that's not strictly part of the 5-number summary. Okay, now, once we've got the 5-number summary, we can draw something called a box and whisker plot, or what Americans call the box plot. And what this is basically showing the 5-number summary in a visual way. So you'll have what's a number line, and on that number line, there will be a box that goes between Q1 and Q3. And then in that box, where Q2 is, or the median, there'll be a line. And then from Q1 going out to the minimum value, we have 1 whisker. That's why it's called the box and whisker plot. And then going from Q3 out to the other maximum value, we have the other whisker. Now, I'm going to do another example properly with you. I'm just sort of outlining the idea at the beginning before we do the questions. So basically, whatever the minimum value in this collection is, and I can see the minimum value is just 9. So essentially, if that's the minimum value, it's going to be in line with 9 on the number line. And then the maximum value, I can see, goes up to there. It's going to be in line with 102. Now, what I want you to do for me now is, can you work out what Q1, Q2, and Q3 are for me, so I can finish my box and whisker plot? So that's your task now. Your task is to work out Q1, Q2, and Q3 for the data set that is on the board. And I'll even put it in a nice big red box. Okay, so I'll give you 3 minutes to do that. So first of all, while you're doing this, let's just check the data is in order. Yes, the data is in order from smallest to biggest. So that's important. Now we want to know 10 is the number of items. And then we need to find the position of these things. So what I did was I said n plus 1, which is going to be 11, times a quarter to find the position of Q1, not the value, the position. So a quarter times 11, actually, because my brain is a bit fuzzy, I really should, yeah, 2.75. So it's going to be between these two values. Now, what do we do if it's between values, okay? And it's quartiles. We simply average the two together. And so we're going to go 18 plus 21, which is 39, divided by 2, and we get 19 and a half. And so this value over here, which is Q1, is going to be in line with 19 and a half. Or a Tiware, we are on the same planet, definitely. Who wants to give me Q2 and Q3 before I give away the answer? Q2 is 26 so far. That looks about right if you look at the data. Okay, let me bring up my answers. Let's see that I have the right thing. 65, Q1, 21. Have I got the wrong? Okay, let me just quickly, I think I've got the wrong example there. So basically, if we go, where is the middle? This is going to be 5.5. So 1, 2, 3, 4, 5. Halfway between 23 and 26 is going to be 24.5. So that's going to be this one over here. And then Q3 is going to be 3 over 4 times 11. So divided by 4 times by 3, 8.25. So 1, 2, 3, 4, 5, 6, 7, 8. And so halfway between 65 and 101, I get 83. And so that's the answer. Now, you'll notice that it looks a bit wonky because my graph isn't drawn to scale. So in the next thing, what we're going to try and do is use more of a scale. But I think I've given you a basic idea for how this works. So we're going to move on to a practice. Actually, I'll leave it up for a second. Can I move on? Just give me a thumbs up if you've managed to check your answer, and then we can do another practice question. Thumbs up, love it. Give me a thumbs up if you're ready to move on. Lumka, thank you very much. Fantastic. Okay, let's put these new skills to the test. Now it's time for you to fly solo. So what I want you to do is I'm giving you a data set, and I'm going to zoom in because I know it's a bit small. And I want you to draw me a box and whisker plot. Okay, totally. So Tumelo, that it's not a problem. What I'm going to do is I'm going to work through this question in detail. And while I'm doing through the sub steps, I want the students to feel comfortable moving ahead to the end to do that. And I'm going to go through every little detail now. And you just hang in there, Tumelo. And if you need me to slow down, just pop a message and Ozan will get me. Okay. And she'll slow me down. So basically what I'm doing is I'm drawing a graph, but you need to know why I'm drawing this graph. And the graph itself is showing characteristics about this data set. Often where I'm leading to with this is often we have to compare two data sets. And so we need a graphical way of representing data that highlights the different characteristics of them. So one of the ways of doing it is to calculate something first called the 5-number summary. And the 5-number summary is exactly what it sounds like. It summarizes the behavior of the data. So in this question, in the 5-number summary, I need the minimum value and I need the maximum value. So I want you to first find me the minimum and maximum value. First of all, do that. Then when you've done that, we're going to find what's called the first quartile, the second quartile, and the third quartile. And what these are like the fences. The Q2 is like the middle fence. It chops the data into 2 equal halves. And Q1 chops the data into like the lower half into a half. Or Q1 is probably going to be somewhere around here or around here. I don't know yet. Now, in the previous lesson, we worked out a way of saying, look, if I want to find what Q1 is, I first need to find its position. And so that's what the students are doing now. They're finding the minimum maximum value first. And so I want everyone to, if you're not working independently, could you pop the minimum and maximum value into the chat? I want to see, can you see what the minimum and maximum value is? I'll give you a moment there. Totally. 503 is the minimum. Perfect. Okay, perfect. Okay, so you've already got 2 out of 5 here. Now we need to find the quartiles. So the position, now this is not the value of Q1, this is the position. The way I'm going to do it is because it's a quartile, I put a quarter in front. And now what I'm going to do is I'm going to say how many items in total are there? And this feels a bit artificial. If you watch the first video, I went into a bit more detail. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, what is a little bit sneaky is I don't go 15 here. I go 15 plus 1. And the reason is it's about dividing things up between boundaries. So, but I need to probably go, but you can watch the earlier video for that one. Now, if I say, look, I've got 16 divided by 4 or 16 times a quarter, the thing in the 4th position is going to be Q1. And so Q1 is going to be, if I count 1, 2, 3, 4, it's going to be 507. And 25% of the data is down there. And 75% of the data is going in that direction. Okay, so that's what the other students are doing. And I would encourage you, even if you can't finish it right now in real time, watch the rest of the video and see if you can calculate what we see are the answers now that I'm going to bring up in a moment. Before I do that, does anybody like to have a go at Q2 and Q3 and your box and whisk? Well, tell me what Q2 and Q3 is, and we'll see if we agree. Again, what I mean by Q2, because you get so quickly into that vocabulary, Q2 is the median. It's 2 quartiles through the data. And so 50% of the data is below, 50% of the data is above the middle of the data. Okay. I'll give you a little bit more time because I think to draw the box and whisker plot, let me just sneak and get the answer for the actual values. So 507 was Q1. So there's my 507, there's my 503, 526. Q2 should have been 510, and Q3 is 515. Now, when you draw this, actually the drawing is quite nice. If you look at this, I'm just going to scroll down for a second. When you draw this, can you see how you first draw your number line at the bottom with your values on? And then what you have is, they don't actually always even label it with Q1, but you know that Q1 is here, Q2 is here, Q3 is there. And sometimes some textbooks don't put the whiskers, they just put a dot there. Now, what I want to point out is, can you see the whisker on the one side is much longer than the whisker on the other side? Why do you think, what does that mean? Can anybody give me like an idea, or just like why is the whisker longer on the one side than the other? Any ideas? Or what does it mean? Feel free to turn on your mic if you like. Sometimes it's quicker than typing, and you'll get serious ninja points from me if you do. Okay, so what it actually means is each of these bits from the minimum to Q1 is 25% of the data is sitting in that area. Oh, sorry, that was messy. Now, the lowest 25% of the data is packed into quite a small space, whereas the upper 25% is quite spread out. Can you see that? And so what it means is the data is more spread out on the higher side than it is on the lower side. The box shows us the interquartile range, because isn't the interquartile range just Q3 minus Q1? So the middle 50% of the data is sitting in the box. And that's why it's so much easier. If I look at a box and whisker plot, it tells me a story that's much easier to understand than just lots of random numbers. Okay. So to finish today, the last question before the exit ticket, I'm going to give you 2 box and whisker plots, and you are going to tell me some information. So I'm giving you a box and whisker plot on the top, we'll call it the red one, and then there is a box and whisker plot over here. I want you to write down the 5-number summary for A, and I want you to write down the 5-number summary for B. And I'm going to give you a little bit of time, and I'm going to stand up and stretch. And then when you're done, could you please put that in the chat? And the way we normally write the 5-number summary is we write it in order from smallest to biggest. So the first value would be the smallest, the min. And then we have the last value will be the max. And then we'll have space for 3 values in between. And what the summary does is it gives us 5 really important numbers that summarize the data. And in this question, you don't even have to draw it. You've just got these 2 wonderful box and whisker plots. So I'm going to stand and stretch, and you guys see what you can see. Is it big enough, Alzan?
You can probably zoom in a bit. That would be great.
Okay, awesome. How's that?
Perfect. Thank you.
Cool. I think this online teaching is very different to in classroom because you just sit down so much more. And I'm not used to that. I'm going to have to. It's probably tough
Now
for
you
the
can,
students.
yeah,
Yeah.
now we can get a feel what the students has to
Yeah. I know it's
endure
terrible,
every
isn't it?
day.
I know. It totally is, huh? It's like, you never know until you walk a mile in someone else's shoes.
Exactly. We need to sponsor that yoga balls so that everyone
Yeah,
can sit on that instead.
bounce around and yeah, exactly.
Everyone will fall around in class.
Yeah, that's a challenge. No one, yeah. Good core strength. Okay. So basically, all you're going to do is the smallest. Okay, well, let's go with this one. For the red one, the smallest value is just going to be 25. So the first number is going to be 25. The lower quartile or Q1 is in line with 30. So that would be 30. Q2 is in line with that, or 50. Q3 or the upper quartile is in line with 70, and then the maximum value is all the way up here at 140. And so for the first one, you can see that there's a long whisker going to the right. And that means that there's that top set of data is really quite spread out. That top 25% is quite stretched over a long amount. Now for the other one, it looks like all the values are much closer together. And so if I look at it, the minimum value is going to be 5. Then Q1 is going to be 15. Q2 is going to be 20. Q3 is going to be 30. And Q3 is the same. What this means is that the highest value is the same as Q3, which is kind of strange, but it can happen. Now, I would love, okay, so we're kind of finishing off for today, but you can clearly see these two data sets look very, very different. And this is the beauty of the box and whisker. As a teacher, I can ask you questions about like, what is the behavior or what is different about set A compared to set B without having all those numbers and all the clutter of that. I can just say, what are the differences between these two? And so I'm going to end with this question. Which of these two do you think has the higher standard deviation? Okay, so this is me getting very sneaky now. But if you had to give me an answer, what do you think of these two has the higher standard deviation? You don't have to even calculate it. You can just tell me based on your intuition. They're equal? Could be, yeah. Set A, okay, who else? Set A. Okay, I tend to think that set A, because remember, Q2, now look, the standard deviation is measured from the mean, okay? And we don't actually have the mean in this question, but if you look at this graph over here, this graph is much more spread out than this one over here. So one would imagine that A would have the highest standard deviation, okay? Just based on the fact that it's just way more spread out, so you would expect it on average to be further away from the mean. But we don't actually have the mean in the 5-number summary. We only have the median. So I suppose in some ways we're kind of a little bit guessing, but yeah, 99% chance it'll be set A. Okay, folks, this is the end of the lesson. Now, I want to explain to you, I've made something special for you. And I want to, I don't know if there's time to play it right now, but I'd love for you to give us a go straight after the lesson as sort of your kind of just, I'm finishing the lesson, let's try and do this now. And what it is it's an online quiz. And I've got one of the questions from the online quiz just to kind of show you what it's like. So I want you to answer this for me for our exit ticket. And then if you're feeling like I need more practice, you can go to these online quizzes. But let's finish off with this question 1. What does point C on the box plot represent? And the options are A, B, C, and D over here. I'll give you a moment to try and do that. What does the point C on the box plot represent?
Someone is asking, Lumka is asking if you can please zoom in a bit, Peter.
There we go.
Thanks.
The magic of vectors and zooming in. There we go. You guys are winning. Big up. Well done. Okay. So what I also want you to do now is, as a math teacher, I know that practice makes perfect. I can't tell you how often when students realize that it's a bit like exercise. Like when you go to the gym the first time, you're like, how am I ever going to get stronger or get faster? And then people accept that if you train, you get better. And the same thing is true for maths. It's just that a lot of people haven't seen that modeled. And so if you're feeling like you just need a bit of extra practice, these 2 quizzes, especially the first one, this is partially from the other day, but there's actually, both of these should be a lot of fun to do. And then there is some stuff from the app that we have also that Alzan will talk to you about now. Okay, Alzan, I think that is me for today. I've squeezed in quite a lot, but yeah, I've enjoyed it. I hope the students have too.
Awesome. Thank you so much, Peter. I know that I've learned a lot. How are you guys feeling? Can we see some emojis?
Yes.
Are you guys still alive, still awake? We've got a hand clap and a thumbs up and a dizzy face. Thanks for being honest, Tumelo.
Yeah. Honesty is the best policy. And you may have to practice some more. You know, it may be that this was just the beginning. But, you know.
Exactly. Something that I've heard is well-guided practice helps improve. So because we can practice the same thing over and over and it might be wrong. But Peter, because you are guiding the students, I think it's going to help them to practice the right thing from here on. So well done for all of you for attending your second lesson today. As you can see here, you have finished your graphical representation of statistics. So good job to all of you that's been here. Then, like Peter said, you can go and try out that quizzes that he just showed. And if you want to practice even more, go onto the Watobe app. In the topics bar, you will find statistics. And underneath statistics, if you scroll down a bit, there's the subtopic called box and whisker plots. So Peter, I said creating box and whisker plots. Is this the one you were talking about?
Yeah, that's exactly it. Yeah.
Awesome. Guys, so take a screenshot, remember this. And then next week, Tuesday, when we get together again, then we'll have a look at the leaderboard and who has done their lessons throughout the week. Okay, so we're very excited for that. And then just lastly, remember that all the live classes is on our website. And it's also on Watobe's YouTube channel. So if there's something that you maybe didn't understand, or we obviously only have an hour and you want to go back to listen to how Peter guides our practice, then just be sure to go and hop onto YouTube. And you can also share this with your friends. Maybe they can find this helpful as well. Okay. So this is it from us. Do you guys have any questions? Any last comments?
Or what area? Yeah, we always, if you send us questions, I mean, we'll adapt to the information that we get. And so I think it's important to take that ownership of your learning. I know it's a bit new initially, but we'll get to know each other. You'll get to know our personalities. And I do think it's good. Just if you don't get something, just say it. It's really not a problem. And we'll do the best to accommodate as many people as we can. Okay, we want you to feel comfortable, and you're putting in the hard work to be here, and that shows drive already. So
exactly. Well done, guys. Well, enjoy the rest of your evening. Enjoy your quiz, and remember to rest as well. Okay, that's needed.
Thanks,
Okay,
Ozan.
guys.
It's
Bye,
fun.
Peter. Thank you.
Cheers,
Take care,
everyone.
guys. Bye-bye.
Give us a shout out if you can come on now before we go. Let's hear those voices.